Hey everyone, welcome to our next lesson, which happens to be the beginning of chapter 2. So at the end of chapter 1, we went over different possibilities about what needs to happen for the earth to get warmer. And right now we're going to focus more on energy entering and leaving the system. So this lesson is slightly longer than others. I'm going to try to make it as quick as possible, but know that there was a hands-on activity that I'm going to have to demonstrate using the computer to make it work. So we have our warm-up, and it says, imagine you are filling a bucket with water, but the bucket has a hole in it. What will happen to the level of water in the bucket? So I expect you guys to actually answer this question inside of Amplify. So I'm going to go into the Amplify site. You should start on this page, and this should be what you're looking at when you open Amplify. So we have the diagram on the left that shows the water entering and the water exiting. Take a moment, press pause, and come back when you're ready with an answer. Okay, welcome back. I'm actually not going to answer this question right now, but we will go back and think about the warm-up question later on. So let's get into the hands-on activity. So in chapter 1, we found that both energy, temperature and energy absorbed by the surface increases when the amount of carbon dioxide or methane increases. So we're going to focus now on the chapter 2 question. Let me go back into Amplify my slides because I worked really hard. So the chapter 2 question is, why do temperatures on Earth increase when the amount of carbon dioxide or methane in the Earth system increases? So chapter 1, we found that the temperature is increasing because of methane or carbon dioxide, or both, we're not sure yet, but why? Why does it increase? So today we're going to have a smaller focus of what can affect absorbed energy. So we have a letter from Irene Lee, and it's our next assignment. The research you have done so far is impressive. The evidence is strong, and it supports the claim that increased carbon dioxide or methane in the atmosphere is correlated with climate change and the decrease in ice. To make your explanation stronger, I'd like you to investigate how an increase in carbon dioxide or methane could cause increased temperatures. Since you already know that energy absorbed by Earth's surface must be increasing, as a climatologist, the next question is how the amount of energy absorbed by the surface can change. I suggest you look at energy entering and exiting the Earth system, and this will bring you closer to understanding what might be causing climate change. Looking forward to learning from your results. Irene. So, correlate with means one thing seems to be related to the other thing, generally because they happen at the same time. For instance, increased temperature seems to be related to increased carbon dioxide, or increased carbon dioxide seems to be related to a decrease in ice. When things are correlated, it doesn't mean that one thing caused another thing to happen. Correlations can be good evidence, but they aren't strong enough evidence to prove that one thing causes another thing to happen. In your life, in all your science classes, you're going to hear the phrase, correlation is not causation, or it doesn't mean causation. This is because things can happen at the same time, and they may not necessarily be related. For instance, Miss Leonie ate more cheeseburgers in April, and Miss Leonie had more money in April. They might seem correlated because one could cause the other. If Miss Leonie had more money, she could go buy more cheeseburgers. But There might be other things that we don't know about that can cause something. Like Miss Leonie might have had more cheeseburgers because she stayed home and her parents have a grill. So there might be unknowns that might actually be the cause. So when you look for evidence, it has to be directly related and not necessarily a correlation. This is a little hard to understand, but you'll get more of this as you go into deeper science as you get older. So for the warmer today, you thought about water entering and leaving the bucket at the same time, and what that means about the water level in the bucket. This is similar to energy entering and exiting the Earth system. If we know something about energy entering and exiting, we can figure out how the energy in the Earth system might change. All right, so a model is an object diagram or computer program that helps us understand something by making it simpler or easy to see. So we're going to use the energy token model. Now, one of the problems here is that this was supposed to be done like with a different type of tool, but I'm going to try to do it on here just to get started. So what we're going to do, here I made a better slide, is on the side here you're going to see the instructions for each model. Now we have 3 models. At this time I would like you to also go back to your Amplify page, and you will see these model tests here. So there's going to be 3 tests. Again, test 1, test 2, test 3. So let's start with test 1. And it says, what can affect the amount of energy near Earth's surface? Gather evidence to help answer the question by using the energy token model to test the changes to the amount of energy entering. So for the setup, for every test, we're going to start with 10 tokens of energy in outer space and 10 tokens on Earth's surface. For some tests, you need to decide how much energy enters or exits. That's up to you. Energy enters, so running the model, energy enters. Bring the correct number of tokens from outer space down through the atmosphere to Earth's surface. Energy exits. Bring the correct number of tokens up through the atmosphere to the outer space. Repeat this 3 times. Record the final amount of energy. So for test 1, we have energy entering 3, energy exiting 3. And then what's final energy on Earth's surface? So let's go into our slide where I have the diagram here. So let me bring that back to full screen again. So it says start with 10 inside Earth's surface and 10 in the atmosphere. So it says start by moving 3 of them to the Earth's surface. Test. And then move 3 out to the outer side. So I'm going to take 3 of the ones on Earth and move them. Sorry. This might be harder. Let me just... trying to move 3 of these without moving the Earth. Let me see if I can... lock this. I'm going to put them Now I get to move 3 out of the Earth's surface. So this is turn 1. Now again, I'm going to do this. This is going to be very easy. Move 3 in, move 3 out. Easy. Third round, move 3 here, move 3 out. Now, without even thinking about it, each of them still have 10 because we didn't change. When we put 3 in, 3 went out. So if I go back to amplify, I'm going to write the final energy on Earth's surface is 10. We did not actually have a change. It stayed the same. If the same amount enters and the same amount exits, you're going to have the same number. Now, I want you to think about this when we talk about water in that cup. If the same amount of water goes in and the same amount of water comes out, the cup is actually never going to change the amount of water. So let's run test 2. We're going to choose a number greater than 3, but fewer than 7. Let's go with the number 5, right in the middle. So we're going to move 5 at a time, but we're going to enter 5, exit 3. Enter 5, exit 3. So we're going to go back to the slides. We're on energy model 2. We're going to move the 10 here. So we're going to enter 5. So 1, 2, 3, 4, 5. Enter 5, exit 3. 1, 2, 3. Enter 5, exit 3. So now we're at the end of round 2, and now we have our last round, 5, and remove 3. So our final count is 4 in outer space and 16 on the surface. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So again, we're going to go back into the amplify. And what's left on Earth's surface? 16. Now this makes sense. If more is entering than what is exiting, you're at a surplus. That means you're going to keep getting more. The level is always going to increase. And so for the energy in test 2, it increased. The energy increased because we had more coming in than going out. Now, entering 3, and now we're going to choose a number for exiting that's between 3 and 7. And again, I'm going to choose 5 just for simplicity. So again, enter 3, exit 5. Going back to the model. And I have one more, nice and clean. So enter 3. I'm going to move. I'm going to move my 10 down here, so that's where we start. Now enter 3. 1, 2, 3. Exit 5. Enter 3. Exit 5. And the last time, enter 3, exit 5. So now we have the opposite effect, which makes sense because we're going in the opposite direction. We have 16 on the outside, but only 4 left on Earth. So let's go into here. And how many are left? 4 on Earth. So in test 3, the energy is decreased. So what situation leads to an increase in temperature? More energy enters than exits. If you get more than you release, then you're going to have an increase in temperature. So let's think about this in terms of money. If you get $10 every week but only spend $1, you're going to keep adding more money. The opposite is true. Let's say you get $10 and you spend $10, your financial situation is exactly the same. You're at 0. If you get $10 but spend $15, you're going to go in the negative. You're going to be in debt. So when we look at what's going on here, if we enter more energy but don't release the energy, we're going to have a surplus, which would probably lead to an increase in temperature. Which situation leads to a decrease in temperature? Less energy enters than exits. So if there's less energy coming in than there's leaving, we're going to have a lower temperature. So let's hand this in. And let's move on to the next part. Sorry, I just want to make sure I'm on the right page on my notes. All right, so we're going to watch a video on the water situation. This actually might come from another part of we've seen this video, similar video to this before. So we're going to watch this demonstration about entering and exiting. So pay attention.
This is a model for energy in a system. The system is represented by the tank, and the energy is modeled by the orange water flowing through the tank. This top valve allows energy to enter the system, and this bottom valve lets energy exit the system. Right now, both valves are letting the same amount of energy enter and exit. Because of this, the system is stable, meaning the level of the energy in the system is not going up or down. The valves can also change the amount of energy entering and exiting the system. Let's look at 2 ways we can increase the amount of energy in the system. The first way is to open the top valve so that more energy can enter while keeping the bottom valve the same. We can see that the level of the energy in the system starts to rise. Now both valves have been reset to let the same amount of energy in and out. The second way we can increase the amount of energy in the system is to close down the bottom valve while keeping the top valve unchanged. By closing down the bottom valve, less energy can leave the system. This also makes the amount of energy in the system increase. Now we know 2 different ways to get the exact same result. Having more enter or having less leave both increase the amount of energy in the system.
All right, so let me go back to the slides, and we're going to discuss this for just a moment. All right, so a system can be stable even as something flows into and out of the system. We saw this same exact situation happen with population inside of the biodome of matter and energy in the ecosystem, right? Just because the environment is stable doesn't mean that there weren't animals being born and dying, right? So if the energy is stable, that means that just the same amount of entering and exiting. Now, if this balance is disrupted, there might be changes to the system. So in the video, we saw 2 ways for an increase. And we're focusing on increase because we are looking at an increase in temperature. So one way to increase is more energy enters. Second, more energy, less energy leaves. So we can either have more water coming in and not change the exit, or we can have the same amount of water coming in, but less exits. So we're going to look at both of these options. Okay, so we have change and stability. These two words are old vocabulary words, but we're going to use them again. Change is when something becomes different over time, and stability when something stays mostly the same. So something can either be changed or stable. So what happens when more energy enters than exit? We're going to have an increase. What happens when less energy entered than exited? We're going to have a decrease. So a change can either be the amount of energy entering or exiting the Earth's system, and how much energy is absorbed by the surface. So when we talk about the global temperatures increasing, we have two options. Again, I'm going to reiterate that we can either have more energy coming in, or we can have less energy leaving. Okay. I'm going to go back again to this, to amplify. Click next activity. I'm not going to make you, just because of okay, sorry about that. All right. I'm not going to make you do the simulator part, but I do want you to reflect on this on your own. And this part I will be grading. So I want you to reflect on this and keep in mind that if more enters than exits, we have an increase in temperature. So look over these things and you will make your decision for this question on your own. You are not doing part 3. You're welcome to do it, but you're not required to do it because it will take some extra time. All right. And again, sorry that today's is a little long, but tomorrow's is a very short